Hello everyone, and welcome back to another tutorial video. This one will be the first of several in a series of videos I'll be making covering various Laplace transform problems. In this video, I'm going to be covering, relatively shortly, how you can find the Laplace transform of a function by using the original definition of the Laplace transform, which I have written up for you here on the screen. The definition of the Laplace transform of a function f of t is the integral from 0 to infinity of e to the negative s times t times f of t dt. So any problem that asks you to find a Laplace transform by definition is asking you simply to use this formula and calculate this integral. So that's really all there is to it, so let's jump right into an example. Alright, I have written up the example problem I want to go over, which is exercise number 3 from section 7.1. The problem is as follows. We want to find the Laplace transform of the following function using only the definition. The function itself is f of t is equal to e to the 3t plus 1. So all we're going to do, again, is just punch this directly into the definition, and just calculate that integral. So we write that by definition, we know that f of s is going to be equal to the integral from 0 to infinity of e to the negative st times f of t dt. So now we're going to plug in the value of f of t in to get that f of s is equal to the integral from 0 to infinity of e to the negative st times e to the 3t plus 1 dt. Alright, so one thing we can do here, we have a product of two exponentials. That means that we can combine them if we just add the powers. So this gives us that f of s is equal to, once again, the integral from 0 to infinity. And this time we have e to the 3t plus 1 minus st dt. And therefore, f of s is equal to the integral from 0 to infinity of e. And here what I'm going to do in this step is I'm going to factor out the t from the terms that have it in this power here. So here we're going to get, this is 3 minus s times t plus 1 dt. Okay, so now we need to calculate this integral. This is a very simple, you could call this a u substitution. Some of you may have just learned directly a rule for an exponential like this, but it's quite straightforward. So let's say, let's take u equal to 3 minus s times t plus 1. This would mean that du, I should use a different color here. Du is going to be the derivative of this, which is just going to be 3 minus s. This in parentheses with dt, of course. Meaning in turn that dt is equal to 1 over 3 minus s times du. So if we plug this in, we now get that capital F of s is equal to the integral from 0 to infinity. These are t equals 0 to t equals infinity of e to the u times 1 over 3 minus s du. Okay, so now again we're treating s as a constant. I say again, but I should point this out. Throughout all the calculations that you use when just using the definition of the Laplace transform, you will be treating that s as just a constant. You don't know, you assume that it's a constant, you don't know what the value is, but you do not treat it as a variable at all. You just imagine that it's a constant and you proceed with your calculations as is. So what this is going to give us is that the integral of e to the u is, of course, e to the u. So therefore, just plugging this in, or integrating and plugging in u gives that capital F of s is going to be equal to, well, integral of e to the u is e to the u. So we're still going to have the 1 over 3 minus s times e to the u, and u is 3 minus s t plus 1. Which is coming, of course, from there. And then for here, for the values of t, we are going from t is equal to 0 to t is equal to infinity. Okay, so now we need to find the values for which this will converge. So let's just plug these values in real quick. You'll note that when t is equal to 0, this guy, well, this exponent here, t, is going to be e to the 1. So this guy is equal to 1 over 3 minus s times e. So this is going to give us that capital F of s is equal to the limit as t goes to infinity of 1 over 3 minus s times e to the 3 minus s t plus 1 minus e over 3 minus s. Okay, there's only one final thing left to deal with, and that is, of course, this big limit. And keep in mind that in the definition of the Laplace transform, they point out that the Laplace transform itself, this capital F of s, is only defined for values for which that big integral thing converges. So, in other words, this big thing I've boxed in green here, this limit will not always exist. For the values of s for which it does not exist, we consider capital F of s to be undefined. But we will define capital F of s for the values of s for which this does exist. And you will note that when s is strictly greater than 3, this guy up here is equal to 0. And the reason for that is that if this exponent of e, or rather this value here, shall we say, let me pull out. If this number here in front of the t is negative, then as t gets large, this exponential will go to 0. In order for this exponent to be negative, we need to have s strictly greater than 3. If s is not strictly greater than 3, then this exponent, well, either here we're dividing by 0, which we can't allow, or this exponent is positive, and as t goes to infinity, this whole thing will go to infinity, and therefore it does not converge. Okay, so where does that leave us? I'm going to move this up very slightly. I'll probably tone this down a little bit. So what do we get at the end of the day? We get that for s strictly greater than 3, capital F of s is equal to negative e over 3 minus s. Or if you prefer, you can write this as e over s minus 3. All right. That's really all there is to it. The one thing really to keep in mind is, again, when you do these types of problems, when you calculate, or when you're finally getting to this limit over here, having some sort of concern for the values of s for which the limit is defined is going to be necessary. By the way, when you look through, say, table 7.1.2, you'll notice that the table always has some sort of thing mentioning what the values of S are that for which those Laplace transforms exist. And they come as part of this process. They always come at this final step here, checking what values of S allow the limit to exist at the end. All right, that's really all there is to this type of problem. So as usual, if you have any questions or if there's anything that I did not answer here, please let me know, and I will catch you guys in another video.